Hello everyone, I have another video today talking about a new feature in our free Spline Mesh tool. This is the last video of the series of 5 about this update, so you all probably know the spiel by now. This blueprint is available on Fab for free with this link, and you can buy it if you like to help support us and get the demo map that includes meshes, some very basic materials, information, and extraneous blueprints like this one that allows the player to ride a roller coaster. But let's get on to today's topic. Throughout the initial launch of this tool, some of you said that there are still some major issues that you face that seemingly have no solution anywhere. And today, I'm tackling one of those big subjects: solving Unreal's default spline twisting problem. Some of you may not be familiar with this problem, but it occurs when you have spline meshes deforming along the spline, and then make a piece of your spline travel upwards, and it gets all twisted. It goes from 0 rotation to a full 180 degree flip in the span of less than a few centimeters. I'm first about to explain why this happens, so if you're not interested, use the timestamps on the video to skip to the next part. Alright, there's a very interesting reason your meshes are flipping or failing when approaching verticality. But first, we need to know some basics on how the system works. Your spline has 3 vectors or directions at any given point, and your meshes placed along the spline use these directions to orient and twist themselves. It keeps track of the upward vector, the forward vector, and the right vector. You only need 2 of these directions defined in order to figure out the third. The first one is the forward vector, and we can just use wherever the spline is pointed forward, known as the tangent, at that point along the spline. So we have the first vector. But how is the next vector calculated? It is now equally difficult to come up with an upward vector or the right vector that twists correctly. Unreal Engine has the very easy system of just going, well, the up vector is always along the world's positive z-axis, also denoted as 0, 0, 1, which is very flawed for the twisting operations we are now trying to fix, and I'll elaborate why a little bit later. So if we use UE5's system, we have 2 vectors, and our third can be calculated by using some vector math called a cross product. And now we have our 3 directions. Since we have an upward vector that will never change, we need to worry about another vector matching it. Luckily, the right vector is always calculated from the upward vector, so it can never be equal. But the forward vector can be. So when it converges on this point where the forward direction on the spline is the same as the upward vector, it loses all sense of direction. Think of it like making a table with 3 legs. It's very easy to balance except for one edge case. Making 2 of the directions the same on a spline is like putting 2 table legs on the exact same spot, or all 3 in a line. It satisfies the requirement of 3 table legs, but the closer they get together to all being in a line, directly increases the chance of the table falling over, much like the spline suddenly twisting. For the table and the spline, the most stable solution is to have the 3 points going in 3 different directions. So my solution to this is to change the rule of the upward vector is always pointing up the z-axis, and make it so the up vector is pointed more on the xy plane as the forward vector becomes more vertical. And I realize that anybody could come to that conclusion, but the tricky part is actually coding where on the xy plane it should be pointing. I'm not going to get into that because this video would be a bit too long, and frankly boring unless you really like vector math. So let me just continue to show you some of the results from the before and after of using this new method. I can now finally use this roller coaster mesh I created over a year ago that was for this exact demonstration. Starting with the old spline twisting method, you can see on this roller coaster it has parts where it twists kind of suddenly, making it look unnatural. Unreal's default system mathematically works, but not so much visually. Instead, if it was better, it could find a way to span out the twisting over the entire vertical part. I also have another example in the back of this map, where it has 2 parts that are nearly a straight vertical rise and drop. In this example, the meshes don't look like they have a twisting problem, but more so a flipping problem. It is actually a twisting problem, but it occurs over such a short distance, it seems like the meshes just inverted themselves. When we switch it to the new solution, the twisting now looks normal on the vertical drops. And if we do the same on the other roller coaster, the twisting looks smoother as well. The new method is very close to the old method, but adjusts itself when the spline gets more vertical. It will have edge cases where it still has some of the old problems, but it should improve or fix the old method over 90% of the time. If I go back and forth, you can see that where the old Unreal Engine design system failed, the new method corrects itself in a majority of cases. In order to use this new method, you can enable this variable override default spline twisting. There is another variable related to this called untwisting magnitude, and what that does is change how quickly it untwists the mesh around the spline. I have a feeling that it yields better results dependent on the length of the spline it has to try to untwist itself, but I'm not entirely sure. I want to stress that this is a major stepping stone to a more stable spline twisting method, but there is room for improvement. This is a very heavy math-based problem, and if you're not good with vector math operations, it may take you longer than it took me. This required a lot of dot products and cross-product operations, and testing a lot of methods that did not work. Eventually, I settled on trying this vertical override method, since this would resolve a lot of consistency issues. Since most vertical parts of a spline happen between two spline points, it will try to resolve the sudden twisting between those two spline points. So the closer you have two spline points, the less likely the twisting issue will be resolved. The twisting magnitude variable can help with the rate of the spline twisting, but it will require some manual adjustments if it doesn't appear right. We also have a variable that controls additional rolling at spline points. Unfortunately, you can't use the previous method of rotating directly to spline points. There's a few reasons, but the main one is that you couldn't rotate meshes more than 180 degrees in any direction. If this project gets upgraded to C++, this is one of the first issues I would be able to fix with it. The new rolling at spline points variable requires the spline point index and then the amount you want it rotated. Pretty simple, but I will admit I don't like having to hunt down which index I'm trying to rotate. To make it easier, you could select the spline and then the point, and it will tell you the index here. But again, I do acknowledge I had to give up some ease of use to expand the functionality, and hopefully one day I can make it just as easy again. The last big topic I want to cover is performance. Performance is a big thing you should worry about with deformable meshes like these. This new untwisting method uses a bit more math, but it surprised me that it only increases timings by about 1% or so. But the real danger is using meshes that have a lot of vertices, because it will have to deform every vertex in that mesh. For reference, I had a very poorly made version of this coaster track made entirely in Unreal Engine by merging cylinders together, and that had 3,485 vertices and took 4.76 seconds to load each update to the track. Whereas my optimized mesh I made in Blender had 1,168 vertices and took 0.59 seconds per update. Now, I don't know why the time didn't decrease linearly with the optimized mesh. It could be a range of things, but I do know that optimized meshes are way better for deformation. In package builds, I recommend baking all the deformed meshes along the spline to one mesh, as long as they don't need to be changed at runtime. This way you wouldn't experience the loading time of deforming the meshes at runtime in your game. You can do this by going to Actor and pressing Merge Actors, and then Merge. If you have Modeling Tools plugin enabled, I think you can also press Convert to Static Mesh. Both should be fine. But now that it's static, you can apply Nanite if you want to, it has better culling options, it can be used in world partitioning, and more performance stuff like that. For this example, you wouldn't need the coaster itself to move, that would be pretty weird, so it would be better if it was baked to a static mesh instead. The blueprint that allows the camera to follow the track really only needs a spline, so you could keep the blueprint in your package build for the spline only, and just disable the meshes from this variable. That's about all the advice I have for this new system and these updates. If you have any questions, leave them in the comments. Thanks for watching. You can also follow us here on YouTube or on Discord. Until next time.